Hello, I'm Wes. I have Kelsey and Sierra here, and we're going to be talking about algorithmic biases and fairness. Now, we're going to start with a quick introduction on algorithmic biases and fairness, and really just touch about how important this topic really is. So this topic is so important is we want to keep biases out of these decision-making models because we've seen how decision-making models can go wrong. That's apparent here in the 1930s, where redlining was prolific in decision makings on buying a house, where it kept minorities away from certain zip codes just based off of the color of skin. So it shows that discrimination and biases can be so detrimental if they're incorporated in a decision making model. However, algorithms are making these decisions more and more, and we can see that they've been making decisions since the 1980s. Back in the 1980s, St. George Medical School actually incorporated one of the first algorithms to make a decision, and that was already biased, with being one of the first. It actually, if you had a European descendant name, you actually received 20 extra points on acceptance. And if you didn't, you actually received less points. So it just shows that biases were already being incorporated in algorithms since then. And algorithms are already making more and more decisions for us on a day-to-day basis. So making sure we reduce biases and make them as fair as possible will be essential in the future. Now we're going to jump into some relevant scholarly literature and kind of do a deeper dive into these topics. The first topic here is algorithmic bias on the implicit bias of social technology. Now this article really talks about how these biases are implicit, not explicit. So essentially there is no sensitive attributes in the code. We don't have gender, we don't have race, we don't have age in the code. These systems are actually learning these biases through society and through training and through past decisions. So we're feeding training data into these models for decision making, and we're actually coming up to decisions that are equal to or worse than the decision we're currently making. So we're seeing that algorithms are learning these biases through society, unfortunately. So this is really done through the proxy issue. So we are actually replacing these gender and age attributes and putting in new ones like zip code and computer literacy. And we're starting to see that they are actually coming up with the same decisions and are being biased and unfair. So this really shows the complexity and the issue we're facing with getting algorithmic bias under control. Going through this next article here, you can really see here that we have the pitfalls and perils of algorithms. This one is more of a deep dive into these algorithms and trying to distill them down into some key things that we can look at and some ways to mitigate them. So we really these researchers went out and looked and found that there were 8 key bias groups, and they did this by looking at scholarly literature, media, and some other outlets, and they were able to distill them down. And you can see them listed up there. Some of them are social bias, representation bias, label bias, feedback bias. These are all biases we know about and are in human decision making and can be a real detriment to decision making models. So they actually searched out and found 24 mitigation methods. I won't list those. However, some of the key ones were having a diverse work group, having different backgrounds, helping look at these models, not having a black box, but more transparent decision-making models, being able to explain your algorithm and how it came to that decision. So we do have some great mitigation methods. We aren't able to get rid of it completely, but we are able to mitigate it. This last article I'm going to go over before I pass it over to Kelsey is really a developer's perspective. So these researchers actually conducted a qualitative and quantitative analysis of 99 postgraduate and undergraduate students in the IT field. They were able to distill all those responses down and found some very interesting findings. One of the key ones is if you include objective factors or attributes in your decision making, you are able to have a fair, less biased algorithm, and the decisions are more fair. And this is really from the developer's perspective and through this qualitative analysis. Now, if you include sensitive attributes like race, age, and gender, you really do come up with unfair results and unfair algorithms. So it's good to see that these are some of the results we're seeing. Now, through this analysis also, we were able to see that this FATE attribute, which is fairness, accountability, transparency, and ethics, if it's included up front in your algorithm decision, you are able to have a fair, better, and less biased algorithm in the future. One of the surprising things from this article, though, was that of the 99 respondents, they asked how comfortable are you and how much education have you received on this topic? And most of them listed little to none. So it looks like there's a big effort that needs to be put into education and even continued education after graduation to keep these algorithmic biases low and to help these developers mitigate algorithms to make sure that we have better decision making that are fair and less biased for everyone. Now, I'd like to turn it over to Kelsey to go over a few more literary articles.
So after what Wes talked about, I'd like to kind of see what other research things have been going on with algorithmic bias. And a lot of people have looked into how algorithms affect and can be racist and have some issues with gender, as well as in our justice system. There's also papers on racial bias, and then as well as algorithmic bias as well, and several different issues with that. So the next thing is I looked at a research paper and it talked mostly about algorithmic bias and how a lot of other studies have been static and looked at sex and gender discrimination, but it hadn't really gone into like how humans have interacted with machine learning and how it has created an inherent learning process and basically an iterative algorithm bias, which becomes a problem. So this is definitely an issue when it comes to personalized user interfaces, where mostly this is, and the reason is kind of to figure out that if the algorithms using iterative exacerbate the effects of cyclical interactions between the algorithm's recommendations and the people's choices. So this is a model, and it has basically how human beings learn and the language. And then on the other side, it's how machines learn. So that's kind of a cool thing. So you can look at how they interact, and they actually interact very similar in the way human beings learn as machine learning does. We also have a graph kind of showing the difference between just someone regular talking and then an iterative machine learning model as well. So in order to kind of go through this study, there was a couple topics that they went through, including information retrieval is a type of algorithm that causes a lot of iteration bias, and that returns relevant results following users' explicit query. Some examples of that are probabilistic retrieval model and then optimal retrieval model as well. Then you kind of move into the recommender systems, and those are systems that can be divided and based on which data they use and how they predict user ratings. So some examples for algorithms are that, or machine learning things are content-based filtering and collaborative filtering. And recommender systems are based off of human choices. Something else that's used human choices is information filter algorithms, and they help providers with a list of relevant results in response to a query. And that's similar to like a Google search or anytime you type something in to figure out what results you can find. So basically to go into this study, they wanted to figure out by which process people select information to label, and that process with the algorithm selects the subset of information to present to people, and how much the iteration algorithm bias affects it. Does it affect it at all, or how much does it? They used 3 forms of iteration algorithms. They used personalization filter, active learning, and random. They also made sure that they use blind spot bias because, as we know, humans, we try as our best, but we can't always spot out every single bias. They also used a Mann-Whitney U statistical test. So what they found in doing their experiment and doing lots of statistical math is that there is a problem with iteration filter bias, and that it does cause a significant problem in terms of creating algorithm bias. They also found that active learning had minimal, but some when it comes to blind spot, but mostly iteration filter was the biggest problem. So another thing I'd like to talk about is kind of, we've talked about how we have these biases in algorithms. Let's talk about how we can have biases to help, or algorithms to help biases. So Kleinberg and his colleagues basically wanted to challenge the idea of judges and how they come up with bail. And if they could make a model that actually did a better job than judges on deciding if someone was a flight risk and would cause more problems. And they did all the math, they used the exact same inputs, and they found out that the algorithm did do a better job than real world judges in deciding if a defendant would get bail or not, and then would be a flight risk. So this is a huge problem solver when it comes to gender bias and racial issues. And so as long as the data input that you're using and you're using the correct FATE methods to prevent any issues, you shouldn't have any problems, and you can actually prevent bias in some scenarios. Now we're going to go head over to Sierra, and she's going to talk about where do we go from here.
Okay, thank you, Kelsey. So I'm going to talk a little bit about some of the findings and conclusions from the literature that we just went over, and then also just what else there is to learn in this field. So algorithmic systems and machine learning have increasingly become more and more prevalent, as well as important in our everyday lives. These systems are used for things like hiring decisions, loan applications, marketing and advertising, social media, criminal sentencing, and so much more. One of the big ideas behind these processes is to aid in making more objective decisions that are as free from bias as possible. However, it's becoming more and more clear that these algorithms aren't always as free from bias as they intended to be. So there are many different types of biases that can occur even in machine learning. So I'm going to talk about kind of the two main reasons for these biases. So oftentimes evidence suggests that machine biases mimic the normal bias patterns found in implicit human biases, which those are attitudes and stereotypes that we have but may or may not know, so they can know that we have them, so they can kind of be like a subconscious bias. So we cannot assume that the computer-based decision making is that much more objective and freer from any bias than human decision making. And it's important to note that programmers are not usually explicitly trying to write bias code, but sometimes biases can pop up due to human-generated training data that mimics or picks up some of the social and political biases that human behavior reflects. So there can be unintended bias in data, even if that data is really good quality and randomly selected, just due to the fact that social bias is ever present in the environment. So one example of this is Amazon. They had to stop using a recruiting algorithm because it was found to be gender biased. Because Amazon has a workforce that is 60% male and 74% of their management positions are held by men, the data that they used for these machine learning training came from past resumes, which happened to be from predominantly white males. So the algorithm was taught to recognize word patterns in the resumes and ended up downgrading resumes that contain the word woman. And this is just because it was kind of reflecting the bias that was already in its environment. And then the second type of bias can just come about as a result of bad data collecting practices. So things like that the data isn't a good representation of the population, data sets are too big or too small, or the data sets are already inherently biased. So lastly, in the future, I think one of the biggest goals of machine learning and algorithms would be for it to be completely free of all bias. When these algorithms are picking up on subconscious biases present in their environments, though, it may not be possible for them to never have any bias at all. However, there are definitely much more things that can be learned about mitigating these biases as much as possible. So one of the first things that doesn't seem to be used too often in practice is auditing algorithms and machine learning data. So if organizations who are creating and using these algorithms hired outsiders to perform audits on their data, their algorithms and results, it could possibly reduce the amount of bias by having other diverse perspectives that might catch new biases just from their outside point of views. The second gap is that we noticed a lot coming up in our research was that there wasn't really one uniform definition for bias or fairness throughout the algorithm world. And it's well known that when creating an algorithm, one of the biggest purposes is for it to be unbiased and fair. However, this could possibly mean something different to every organization that's creating them. So it's been suggested that there should be a very uniform and literal definition for these words so that programmers and other people that are creating the algorithms know exactly what they're aiming for. and allowing for less variation and possibly less bias. And then the last area that could be expanded upon more is adding more diversity to teams and organizations that are creating these algorithms and machine learning training data. As we learned earlier, algorithmic bias can reflect some of the implicit biases that are found in the environment around it. And so adding more diversity and less chance for biases to form can allow just for the chance to reduce some of that bias that may occur. And then that's pretty much all we have for you today, so thank you for listening.